Hi everyone, and welcome back to this channel. Today we are going to be looking at the code implementation of a doubly linked list, and I've also included unit tests. For a while now I haven't uploaded any video, and that's because I have been having a series of interviews with a company, so that didn't give me a chance to upload new videos. Okay, so I'm very sorry for that. Alright, so I have pushed this code to GitHub. So this is the link to the code, and I'm also going to add it to this video description so that I can check it out and clone it locally. Alright, so without any further ado, I will start explaining the implementation. Okay, so I have implemented this data structure in Golang, okay, but I'll make sure I explain each concept so that you can implement it in any other language that you use. So over here we have the code implementation, and over here I have the unit tests. Okay, so the first thing to note here is the doubly linked list struct. Okay, so a struct is like a class in Java or in JavaScript. So the doubly linked list struct contains three fields, which are the size of the doubly linked list, which is an integer. We have the head field, which is a pointer to a node, to the head node, and we have the tail pointer, which is a pointer to the last node in the doubly linked list. The second struct that we have here is the node struct. Okay, so this is how a node will be represented in the doubly linked list. So a node contains three fields, which are the previous pointer, okay, which points to the previous node. We have the data stored in the node, which is an integer, and we have the next pointer that points to the next node after that particular node. Okay, so that is the node struct. Okay, so the first method that we have here is the clear method. Okay, so what this method does is to clear the entire linked list, and it does this by deallocating all the elements in the linked list, and it does this in linear time because it has to traverse the entire doubly linked list and deallocate each node. Okay, so first we're going to create the trav pointer that will point to the head node. Okay, then we're going to check if the list is empty. So if the list is empty, there is nothing to deallocate, so we just return true. Okay, but if the list is not empty, then we're going to traverse the linked list. Okay, so basically we're going to extract the next pointer, then we're going to set the next pointer and the previous pointer on trav to nil. Okay, then we're gonna set trav now to the next pointer that we extracted here. So this way we're going to traverse the entire linked list, the entire doubly linked list, and deallocate the nodes. Then once we are done, we're going to set the list tail, the list head, the list tail, and trav all to nil. Okay, we're going to set the size to 0, and we're going to return true. So that is how you clear the doubly linked list. The next method that we're going to look at is the list size method. So this returns the size of the doubly linked list. So that's basically what this method does. Then the next method after that is the empty method. Okay, so this checks if the doubly linked list is empty or not. So we're going to check if the size is empty. So if the size is empty, then we return true. and if it is not empty, we return false. Okay, so that's what this method does. So the next method here is the add method. Okay, so on default, when you call this method, it adds the element or the node to the end of the doubly linked list. Okay, and that is why we're using this method over here. So I'm going to explain this method as we move on in the code. The next method we're going to check out is the index valid method. Okay, so this is just a bound check method that checks if the index is valid or not. Okay, so this takes in the index parameter and it returns a boolean. Okay, so if the index is less than 0 or the index is greater than the size minus 1, okay, and we are doing this because we are starting the indexing from 0. So if the index is greater than the list size minus 1, we're going to return false. So that particular index is not valid, otherwise we return true. Okay, so that's the function of this particular method. The next method that we're going to be checking out here is the add first method. Okay, and what this method does is to add a new node to the front of the doubly linked list. In some cases, some might call this the unshift method, but I called it add first for simplicity. This method takes a constant time because we always have a reference to the head of a doubly linked list. The first thing to do is to check if the list is empty. So if the list is empty, we're going to create a new node. Okay, and this new node, the previous pointer is going to point to nil, because number one is the head node, and the previous pointer in the head node must point to nil. Okay, and this is also the only node in the linked list, right? And also we're going to store the data in the new node, and the next pointer in this new node will point to nil. Okay, because it is the only node in the doubly linked list. So after this, we're going to set the list head and the list tail to the new node. Okay, so this is the case if the list is empty. So if the list is not empty, we're going to set the current head previous pointer to a new node, and for this new node, the previous pointer will point to nil, right? Because it's going to end up becoming the head node, right? And also we're going to store the data in the new node. And also, very important, we're going to set the next pointer of this new node to the current head pointer. Okay, then after that, we're going to set the list head to the list head previous pointer. Okay, so this can look very, very confusing and complicated, but I would advise you to pause the video and review the code yourself. Okay, so the code is quite self-explanatory. Okay, just check it out. Then once we complete this process, okay, we just added a new node. So then we're going to increase the size by 1. Okay, I'm going to return data. That was the data that was added over here. So this is how you add a new node to the front of a linked list. Okay, so the next operation that we're going to be looking at is the add last method. Okay, so the add last method helps us add a new node to the end of the doubly linked list. Okay, so this method can be called the push method. In some you can use the push method if you want, but I've used add last here for simplicity. And also this method takes a constant time, and that is because we have a reference to the tail pointer. Okay, so the first thing to check is if the list is empty. Okay, so if the list is empty, then we're going to create a new node, okay, and set the previous and the next pointer to nil. That is because it is the only node in the doubly linked list. Then we're going to set the list head and the list tail to the new node. Okay, so this is the case if the list is empty. Otherwise, if the list is not empty, we're going to make the list tail's next pointer to point to a newly created node. Okay, and the previous pointer in this newly created node is going to point to the current tail. Okay, we're going to store the data, and the next pointer is going to point to nil, because at the end of the day this newly created node will be our tail. Okay, then we're going to set the list tail now to the list tail's next pointer. Okay, so this is where you actually do the switching. Okay, so this is where you set the tail to the newly created tail. Okay, all right, so after this operation, after these steps, we've added a new node, so we're going to increase the size by 1. Okay, and that's what we're doing over here. Then we're going to return true, meaning that the addition is successful. So that's the function of this particular method. The next method that we're going to check out is the pick first method. Okay, so what this method does is to return the data or the elements stored at the head node. Okay, so it's a very simple method. If the list is empty, we're gonna log a fatal error, okay, saying that empty list. Okay, so you can't return a data in an empty list. That's impossible. So we return this, we log this error over here. Okay, so but if the list is not empty, then that's this case. Then we're gonna return the data stored at the head node. Okay, so that's the function of this method over here. And also similar to this, we have the pick last method. Okay, so pick last method allows us to check the data that is stored at the tail node. Okay, so if the tail is empty, we're going to log an error to the console that it's an empty list. Otherwise, that's this case. Then we're going to return the data stored at the tail node. Okay, so that's the function of this method over here. Now we're going to look at the remove first method. Okay, and just as the name implies, remove first is the method that allows us to remove the head node. Okay, so, and that takes a constant time because we have a reference to the head node. Okay, this can also be called the shift method, but I've called it remove first for simplicity. Okay, so the first thing to do is to check if the list is empty. Okay, so if the list is empty, we're going to log an error to the console that the list is empty. So you can't remove an element from an empty list. That's not possible. Okay, otherwise we're going to extract the data stored at the head node. Okay, then we're going to set the list head to the list head next node. Okay, then we're going to set the list head previous pointer to nil, right? And this is very important because if you're in a language like C or C++, you have to manually deallocate the memory allocated for a particular node, okay, or for a particular pointer. Okay, now if after this removal the list is now empty, then we're going to set the list tail to nil. Okay, so if the list is empty, then we must also set the tail to nil. Okay, then after that we're going to reduce the size by 1, and we're going to return the data that we just removed. So this is how you remove the first element in the doubly linked list. Okay, so now let's check out the remove last method. Okay, so this can also be called the pop method. Okay, but I've called this remove last over here for simplicity. This method takes a constant time, and that's because we have a reference to the tail node. Okay, so the first thing to do is to check if the list is empty. So if the list is empty, we're going to log an error to the console, and that's because you can't remove an element from an empty list. Otherwise, we're going to extract the data stored at the tail. Okay, then we're going to set the list tail to the list tail previous node. Okay, then now we're going to set the list tail next pointer to nil. Okay, because a tail next pointer must always point to nil, right? Then if after this step, okay, if the list is now empty, then we also have to set the head to nil. Okay, then after this we just removed a node, so we have to reduce the size by 1 and return the data that we just removed. Okay, so this is how you remove the last element in the doubly linked list. Okay, so now let's check out the remove last method. Okay, so this can also be called the pop method. Okay, but I've called this remove last over here for simplicity. This method takes a constant time, and that's because we have a reference to the tail node. Okay, so the first thing to do is to check if the list is empty. So if the list is empty, we're going to log an error to the console, and that's because you can't remove an element from an empty list. Otherwise, we're going to extract the data stored at the tail. Okay, then we're going to set the list tail to the list tail previous node. Okay, then now we're going to set the list tail next pointer to nil. Okay, because a tail next pointer must always point to nil, right? Then if after this step, okay, if the list is now empty, then we also have to set the head to nil. Okay, then after this we just removed a node, so we have to reduce the size by 1 and return the data that we just removed. Okay, so this is how you remove the last element in the doubly linked list. The next method that we are going to be looking at is the remove method. Okay, so what this method does is to remove the node that was passed as a parameter. Okay, and it takes a constant time because we have a reference to the node we want to remove, right? That was what we passed over here. Okay, so this is one of the most important method in this doubly linked list. The first thing we're going to do is to check if the node is a head node, and the way we do that is to check if the previous pointer points to nil. So if the previous pointer points to nil, it is the head node, right? So we just call this method called remove first. Remember, we already explained this earlier, right? Also, after that step, we're going to check if the node that was passed, okay, is a tail node. And how do we know if it is a tail node? If the next pointer for that node points to nil, then we know that it is the tail node, right? So we just call this list.remove last method. Okay, remember we explained this earlier. Okay, then now this is the major step to remove the node. So we're going to set the node's next previous pointer to the node previous pointer. Then we're going to set the node previous next pointer to point to the node next pointer. Now, I mean, this is kind of like very confusing and a bit complicated, and I understand, and that is why I've created this image to describe this particular part of the code. So I'm gonna swap to the image now so that you can check it out. So let me explain this concept with this image over here. So the first thing that we did was to say node.next.previous points to node.previous, right? Okay, so let's bring that here. So this is the node. So node.next.previous points toward node.previous. Is that I believe that is kind of explanatory, right? So node next previous points to node's previous. So that's what we're saying over here. So node next previous points to node's previous, right? Okay, so the next one is node previous next points to node.next. So node.previous.next points to node.next. So let's take that to this image. Node, this is the node, right? Dot previous, right? Dot next points to what? Node dot next, right? Okay, so that is that, right? So node dot previous dot next points to what? Node dot next, right? So that's basically what we're doing over here. So that is the explanation for the two operations that we performed over here. Okay, so I believe you have checked out the image, and now you understand the function of this part of the code. Okay, so this is where you actually do the deletion. Okay, so basically you make the pointers of the adjacent nodes skip over a particular node. Okay, then after we complete these steps, okay, we're gonna reduce the size by 1, right? Because we just removed we want to remove a node, right? Then we're going to extract the data stored at the node we want to remove, right? Then we're going to set the previous pointer in and the next pointer for this node that we want to remove to nil. Okay, so this is where we deallocate that particular node. Then we're going to return the data stored as the node. Okay, so this is how you remove a node in the doubly linked list. Okay, so this function will be reused in another method. Okay, but we need to understand how the method itself works so that when we see it later in the code, we won't be confused, right? Okay, the next method that we're going to be checking out is the remove at method. Okay, so what this method does is to remove the node at a particular index, and that is why we are passing the index as a parameter over here. This method takes a linear time because we have to traverse the doubly linked list. Okay, so the first thing we're going to do is to check if the index that was passed is valid. Okay, so if the index is not valid, we're going to return an error to the console saying that the index is not within range. Otherwise, we're going to create this variable called node to remove, and this is going to be a type of a pointer. Okay, a node pointer, right? Then after that, we're going to be smart about this remover. Okay, so think about this, think of this, right? So if the index that you passed is less than half of the size of the linked list, then it's better you start traversing from the front of the linked list, right? And if the index that you pass over here is greater than half of the size of the linked list, then it's better you start traversing from the back of the linked list. Okay, so this is just a kind of optimization to this implementation. Okay, so in this case, the index is less than if the index is less than half the size of the doubly linked list, then we're going to start traversing from the head. Okay, so we're going to traverse, and at the end of the day, we're going to set this node to remove pointer to trav. Okay, so at this point, this trav is going to be the pointer to the node that we want to remove. Okay, so otherwise, if the index is greater than half the size of the doubly linked list, then we're going to start traversing from the back of the linked list. Okay, so trav is going to point to the tail pointer, right? That will begin to traverse. Okay, then at the end of the day, we're going to set the node to remove to trav. So at this point, trav will be the pointer to the node we want to remove, and that is what we are also storing here. Okay, then after this step, right, we're going to return this method remove. Okay, and this is going to remove the node that we actually want to remove, right? So at this point, this node to remove will be the pointer to the node we actually want to remove. Remember, we explained this earlier, right? This particular method. Okay, so this is how you remove a node at a particular index in the doubly linked list. The next method that we're going to be looking at is the get method, and what this method does is to return the data stored in a node at a particular index. Okay, so that is why we are passing this parameter over here. It is used to signify the position of the node in the doubly linked list. This operation takes a linear time because we have to traverse the linked list. In the worst case, we have to traverse the linked list up to the last node, right? Okay, so the first thing to do is to check if the index that was passed is valid. Okay, so if the index is not valid, we're gonna log an error to the console saying that index is not within range. Otherwise, we're gonna create a variable, a pointer right over here, a node pointer over here, and this is gonna be the node that we want to return the data in it. But for now, the pointer is just a pointer, right? It's not pointing to any node as at now. Okay, so what we're going to do next is to check if the index is less than half the size of the linked list. So if that is the case, we're going to start from the beginning. We're going to start traversing from the head. Otherwise, if the index is greater than half of the size of the doubly linked list, then we're going to be starting from the back of the linked list. Okay, so the first case over here is when the index is less than half the size of the linked list. Okay, so we're going to traverse from the head. As you can see, that trav is currently starting from the head. Then we're going to traverse till we get to the node that we want. Then once we get the node, we're going to set the node pointer to point to trav. Okay, so that is the case if the index is less than half the size of the linked list. Otherwise, if the index is greater than half the size of the linked list, then we're going to start traversing from the tail. Okay, so you can see that trav currently points to the tail. Okay, then we're going to traverse like this and take note that we are for each iteration we are setting trav to trav.previous because you are traversing from the back, right? Then we're going to set node to trav. At this point, this node pointer is going to store the trav pointer, right? It's going to be set to the trav pointer, which is the node that we want to remove. Okay, then we're going to return the data stored at this node. So that is how this operation works. Okay, the next method that we're going to check out is the index method, index of method. Okay, and the function of this method is to return the position where a value is stored in the doubly linked list, and that's why we're going to be passing the value parameter over here. Okay, so this operation takes a linear time because we have to traverse the linked list, right? The first thing we're going to do is to check if the list is empty. Okay, so if the list is empty, we're going to return fatal, an error, okay, that the list is empty. Okay, you can't get a value from an empty list, right? Otherwise, if the list is not empty, then we're going to create a trap pointer that points to the head initially, and also we're going to create the index variable that will be set to 0 initially. Then why trav is not equal to nil, that is why the node is not nil, right? We're going to check first if trav.data equals to the value that was passed. So if this is the case, just return the index, okay, which is going to be the position. Otherwise, set trav to trav.next. Okay, so this is how we kind of traverse the doubly linked list, right? And also we're going to increment the index by 1, and that's what we're doing over here. So if the value is not found, okay, so if we perform this operation, this step, and the value was not found, we're going to return -1, meaning that the data wasn't found. The next method that we're going to be checking out is the contains method. Okay, so this basically checks if a value is contained in the doubly linked list or not, and it's linear, right? Because we have to traverse the doubly linked list. Okay, so we're going to pass in the value over here. Okay, the value that we want to check if it exists or not. Okay, so we're going to check if the list is empty. If the list is empty, then return false, meaning that you can't find this value in the empty list. Okay, and this is kind of like rational, right? You can't get a data from an empty list. Otherwise, you're going to create the trav pointer that initially points to the head. Then why trav is not equal to nil, meaning that why the current node is not nil. We're going to check if trav.data is equal to the value. If that's the case, then return true, meaning that we found this value, right? Otherwise, we're going to set trav to trav.next. That is how we traverse the doubly linked list. Okay, otherwise, if all this process was completed and we couldn't find this value, then just return false, meaning that we did not find that value. Okay, so that is how that is what this method contains does. Okay, so the last method here is the toString method over here, right? So this is kind of like a method that helps us print out the doubly linked list as a string. So that's basically what this does. So I'm not going to spend time explaining this. This is just to print the doubly linked list as a string. Okay, you can just check it out, right? But it's not really very important. Alright guys, so this is how you implement the doubly linked list from scratch. Okay, so this is I've just explained the code implementation. Then over here I've written the test to test each method and ensure that it performs the operation as expected. Okay, so if I go ahead and try to run the test now, I'm expecting all the test cases to pass, right? So if I do something like go test -v, all right, so all the tests are passing. Okay, so yeah, that's it. Then over here, like I said at the beginning of the video, I have the code at this GitHub repository, so you can go ahead to clone the code locally, so you can check it out on your computer system. And please don't forget to star this repository so that others too can find it out easily. Don't forget to subscribe to this channel. Okay, so that's very important. This is a series and I'm gonna be releasing the next video very soon, and I don't want you to miss out. So please make sure you subscribe to this channel so that you can be notified when a new video comes up. Okay, thanks for staying till the end of the video. Bye.